Okay, so this is the Data Science Lab in Medicine module and course, and this is the module of Medical Imaging and Big Data. We will start with a quick introduction of what the course will be about, what we will do, some surveys, and then we will start in half an hour with the actual course topics. So, a very quick background. Why is this topic of interest? We have, this is the list of number of FDA approved. The FDA is the American regulator of medical devices, and not only medical devices, but also. And this is the number of medical devices. This means actual objects that are in use in hospitals that contain artificial intelligence and machine learning, or machine learning within them. And you can see that there's been an exponential explosion. Here in this slide, you can see a link, which is live. The FDA updates every couple of months with the list of all softwares that do this. I mean, we'll have a dedicated lectures on what's, according to the regulator, what is a software, what is a device, what is an object that contains artificial intelligence software and things like that, but that's not really the focus of the course. And one of the most important things to notice, on the left column is the approval rate by year. And you can see that we really had a huge number of approvals in the last 3 or 4 years, well, 5, let's say. And the most interesting things is that radiology, the part of medicine which is focused on images, has 500 medical devices approved for clinical use that contains artificial intelligence. The next category is 1/10 of that. It is cardiovascular. But in cardiovascular, you might have ECG, which includes some signals that can be processed linearly with convolutional neural networks, or some images from echography, then neurology. And then you have most of the devices that reach the level of maturity to go into the medical field, which is highly regulated, deal with images. And why is that? Now, this is probably, you've seen this, some variation of these slides lots of time if you're in this degree. If you, these are the results of the ImageNet competition, where you had to develop some kind of algorithm to recognize what an image contains, what kind of object is present in one image. And the errors used to be around 30%, 40%, or things like that. In 2011, with the first convolutional neural network, the error dropped to 16%. And in 2017, 28 out of 39 teams had an accuracy higher than 95%. So starting from that, you can see that back then it was all convolutional neural networks. In imaging, transformers were not common or things like that, but you could get to a super high precision higher than the accuracy with which you know the gold standard data set. Because if you take a look at the images that in 2017 the winners were failing on, are images that you could not recognize with your own eyes, because maybe it was a very small square of a part of a pizza where you could see just red and white, and even yourself could not recognize that. So the technology is quite mature now. What we will cover, as the director of the master degree in data science was remembering us in the last coordinamento didattico, the scope of these courses is, of these data science labs, is to give you some domain competence more than the technical aspects of statistics themselves. So we will have a good part concerning imaging, medical imaging, the principle of medical imaging, and so we'll see what we call image formation physics. So when you get a CT scan, an X-ray scan, an MRI, the image that the physician gets displayed, what is it, where it's coming from, what it's used for, very quickly. And I haven't introduced myself. I am a physicist. I also have an accreditation as medical physicist, which is the professional which goes into hospitals to certify that everything that has to do with radiation and patient is up to codes. And before becoming professor here in the university 3 years ago, I worked 12 years in nuclear medicine. So I have lots of clinical experience, but of course I'm not a physician by far. And we will cover the principle of image formation, as said, then some basic pre-processing techniques just to know what we're talking about. Now, I will ask your feedback about this. Last year, I asked the students after the end of the course which topics they were interested in, what they wanted modified. And they told me that they would have been interested in artificial intelligence-based image reconstruction and denoising techniques. While for a degree in data science, before that I was just talking about diagnosis and classification or other kinds of projects. So if you're interested, this is a really interesting topic. It's a huge topic because even image generation using diffusion starts from the principle of denoising, so it could be really huge, but of course we could cover like 1 or 2 lectures. Are you interested in that? Basically, what is denoising, focused on medical images in our case? So, okay. Then we will quickly go over some traditional classification technique of images. Then convolutional neural network-based techniques for classification. And then we will finish with the analysis of some published experiments, focusing on validation if possible. Now, material in these slides, we will, I will give you the PPT slides and you can click on the links. We have an open book on medical imaging. These 2 books are really, really comprehensive. So you can just open it if you want to go deeper on some specific topics. Of course, I will not go very much into deep details. Then I have a Google Drive repository where you find all my slides, some freeware slides from other centers, some Jupyter notebooks, and the data to be used in exercises. About this, this is a laboratory course, as you know. So you will need to run some code. Are you all comfortable with you running Jupyter notebooks on your own laptop? Of course, the university is investing in getting more rooms with more power plugs, but they're not ready yet. So we have this room and another one for Thursday, and so you will need to work on your own laptop, which some prefer. That's okay. I've written TensorFlow and Keras, but we will discuss about that now. Now, the course outline is 25 hours. It's relatively quick. The official declaration is 7 hours of lectures and 18 hours of laboratory. We are always in this room, so it's really a bit of a tricky distinction. So this is to mean that it will not be theory heavy. And we have 3 hours on Monday and 2 hours on Thursday, which is not late anymore. It's still at this time of the day. And any question about the course program? Okay. The last thing, we have the details about the exam. We will have, this is copied straightforward from the syllabus, so it should be no surprise. We will have a very small theoretical part and a laboratory part. Concerning the laboratory part, you will be given a group task, and you will be evaluated according to the quality of the techniques used and on how you present the results. And the theoretical knowledge will be assessed in an oral examination. You will, I will give you a selection of scientific papers that talk about the application of machine learning or artificial intelligence in medical imaging, and you need to produce a recap of the paper and illustrate it to me to show me that you understand. And I will generally ask one question about this, one or two questions. Okay. So that's it from the intro. Do we have any question? Okay. Now, I have put on the e-learning a link to the course repository. This is a Google Drive. It's mostly empty by now, for now. Interesting. Okay, well, now we have just two folders with slides and exercises. We have something which is not even fully ready yet. And I will upload the Jupyter notebooks and things like that and data with time. Now, the other thing, I guess you're used to WooClap from other courses. So this is a tool to be used for surveys, and we'll use it maybe to do some recaps from in the next lecture, so just to refresh the content. And you can either from your browser on your laptop go to this website and enter that code, or open from your smartphone using the QR code. I have some, I will use this as a survey about a couple of tasks that we need for this course. Okay. So now the first question, this is anonymous. And we know that this is especially the second semester of the second year. We have lots of people that have stages in the industries and things like that. So I wanted to ask you where you plan to mostly attend when possible, or to study on your own according to different topics. If you need me to show the QR code again or things like that, just ask, so that we can, I can use that to better plan how to handle this. I will be recording most lectures. Well, I will recording all lectures. The last 2 years, I was also doing a WebEx streaming, but it was not really popular, and also I don't know how effective it is, given that the audio quality and the video quality and the possibility of interaction is not great. But if somebody asks for that, I can do that. Okay. Well, okay, so that's good. Next, okay, so we have 3 hours. 3 hours slot on Monday, starting around lunch break. So this is a lab course, so we'll try to do just one break, mostly. So we can decide whether we prefer to start early or start late. Let's just agree on that. You have one missing voter yet? We could we could make different results. Since only 10 have voted. Out of the 10, the 11 connected, until the 10 who wanted to vote for the middle choice. Okay, that's a abstainee. So we will start at 1. Same question for Thursday. Now, if I remember correctly, this specific Thursday, we don't have lectures. Okay. In general, okay, for Thursday we can decide every day if we wanted to do one quick break or no breaks or whatever. Okay, this seems pretty unanimous. So we will start at 1 on both days, I'd say. Now, some question about your prior knowledge. About signal processing, we don't need a lot of that, but about signal processing and imaging, like sampling theorem, how images are shown and things like that. Okay. That's similar to previous years. Okay, so that's okay. Now, about deep learning, can you, like, if you had to build a simple model, of course, some convolutional neural network, nothing fancy, not a billion parameter model, but okay. Okay, so, and that's the last question. I've written in the slides that we will do something with Keras, but so I've seen that last year we had many students that were more comfortable with PyTorch, so I mean, especially given the lack of computational resources, we will not build anything super fancy. We will not have many modules to build during the whole course. Okay, that's a perfect tie, I would say. So I will make up my mind about that, maybe. Okay, so that was the last question of this survey, and okay, just another quick thing. We have 25 hours of lectures. We have 5 hours a week. So this means that we will probably end by April 7, if I did my calculation correctly, because we've been requested to do all the courses at the earliest possible. And generally, I offer the possibility, well, it's not that I offer it, I've been asked to provide the possibility to do a pre-examination in early May or mid-May, so that, of course, that's fully optional, but I see that often the students really prefer this, and we will agree the date together by the end of in the last lecture or the last two lectures. Now, another things that I want to gather some small feedback on is how to run these Jupyter notebooks. Do you have, because the idea of the laboratory will be that at a certain point I give you some tasks to do. And the way that I do this in the past is to have some notebooks with just instruction and comments and maybe just some suggested libraries and the basic commands for that specific library that I guess that you will never, that you haven't seen now. Sorry. It's vediamo se non toccandolo più. Okay, so but sometimes I notice that it's not really, the students really don't like programming here in class because then the thing will be that you start programming and I go around and talk with each other. So I don't know if you have any different preference about that or if you have seen a particularly effective way to do this in other courses. So just let me know. And